team. We've got the awesome guys here from GitHub. We've got Tom, Scott, and Chris over here. They're going to give us a nice big overview of Git and GitHub and tell you how awesome it is. So enjoy.
All right, thanks everyone for coming. I'm going to give a talk called Social Coding. It's basically going to be a short overview of GitHub. And then we've got two more little presentations from these guys. So you get a little taste of everything that's going on over here. So my name is Tom Preston-Werner. I work at, my Twitter is Mojambo, and that's generally what I go by online. So if you're looking for me, that's the name to use. I work at GitHub, obviously, co-founder. And a couple things we do there. GitHub itself is a social coding site, as we call it. It's a place where people can come together and work on code, share code, fork other people's code, get copies of it using the Git workflow. It just makes the Git workflow and the way that Git does things very simple, and we try to make it as easy as possible. Another thing that we do is training. Scott Chacon right here is available for training to companies all around the world. He's done training at places like Google and Qualcomm, et cetera, that are starting to use Git internally. We also just came out with a product called GitHub FI, which we call the Firewall Install, which is a locally installable version of GitHub. So if you guys find GitHub really cool and you want it for your department, we can help you get it installed within the company, and you can start using it for your own development teams. It's private, it's hosted within the company, so it's not shared with anyone else, very secure, and that's what it's for. So what are Git and GitHub? I'm going to, instead of saying a lot of words, I'm going to try to show you with little videos of how a normal Git workflow kind of works, a way that you can be working on code and someone else can come in and help collaborate on that code. So, me, Mojambo, let's say I want to create a new project, and it's going to be aimed at having people develop with me later on. And I just want to create it and then get it out there so that other people can see it and start working with me on it. So, I open up my terminal. I got nothing yet. So, here's what I'm going to do. I'm going to make a new directory. Project's going to be called Endo. I'm going to go into that directory. I'm going to create a little README file. It's just going to say hello world. Next thing I'm going to do is do git init. That's the command that sets up a new Git repository. Because Git is distributed, it means that you can work entirely on just your computer. You don't have to have a central server anywhere. So running git init creates a repository that's self-contained on your computer, and only you have access to it. But all that happens locally. Next thing, you're going to add dot. Dot says add every file within this directory and underneath it. So that just says take the content that I created, the README, and stage it into the Git repository. I'm going to do commit-a, which says commit everything that's in the stage. Give it a little message. And now I've got a Git repository that has that README in it. And the next thing I want to do is I have it locally, but I want to share it with the world, so I need to put it somewhere. So with GitHub, we make it really easy. And all you have to do is log in. You have an account. Log in. Say, create a new repository. Give your repository a name and a description. That's all you need. Say next. That sets up a place for you on GitHub, and it gives you some instructions on what to do next. So if you are if you're very new to GitHub, you want to set up your username and whatnot so Git knows who you are. That's at the top there. Next steps are, if you haven't done anything yet and you're creating a new repository, it just gives you a little sequence of commands that you can run, just a little hint for you as you're going along. And what I did is I already have a repository, and I'm already in it. So all I need to do is run this command, this git remote command. What that's going to do is add GitHub as a remote. And in Git parlance, a remote is a server somewhere that is going to act as another location that you can push, basically mirror that content to, the whole repository and all of its history, and just say, I want to push this repository somewhere else. So I'm creating a new remote, which is GitHub here. Come back to the terminal. Paste that in, run that. That sets up the remote. Now that remote is available. Now I can do a command like this, git push origin master, which is saying take the contents of this repository and push it to the remote called origin. And the command previous to that says origin is GitHub. That's just a little alias for me to use, the shorthand version of that long URL. So git push origin and then master. Master is the default branch on Git. It's no different than any other branch, really. It's just the one that is created for you by default for you to use in your normal situations. I could use a different name, but in this case, I'm just saying push up the master branch because that's the only one that I have. So I run that command. That tells me some stuff, tells me it pushed it up to GitHub. If I come back to GitHub and I hit continue here or refresh the page, now you can see that that repository has been pushed up to GitHub and now it's available to the world. So within about 20 seconds, I've created a new repository, added some content to it, made a commit, made a place for that to live on the outside world on GitHub, and then mirrored that up. So it's super, super simple to create new repositories with Git and get them published to the world. You don't have to have permissions on a central server somewhere or anything like that. You can deal with all of this yourself, and it's very simple. So you can see in a nice viewer here that the content is here, the README is there, some details about it. Now let's say that another developer comes along and wants to help me on that project. I told him about it. I told him the URL. I said, hey, check out mojambo/endo. That's the URL on GitHub. And so he can come along and hit that up in the URL. Just type it in, or maybe I sent him a link. So he goes to that repository. And he says, OK, this is Mojambo's repository. Now he's going to fork it. And forking on GitHub is just a way to make a copy of his own on GitHub that he can use for his own purposes and that he can pull down. So he's going to copy this URL, the clone URL for the repository, that he's then going to use to pull down the repository locally to his computer. So he types that locally, gets a copy that comes down. Now he can change directory into that location. And he ran a git status there, which just showed him that that repository was there and the full history. So he has it locally. He can start working on it. What he's going to do is say, hey, this README is pretty lackluster. I think it needs one that's a bit cooler. So he makes a cooler one, saves that. Now he's going to see that it's been changed. Git status lets you see what's been changed. Make a little commit message here. Just say better README, commit that file. And all he has to do now is git push origin master, the same command that I had done earlier to get that content back up to GitHub on his fork. He comes back here. If he refreshes the page, he can see that that content is now there. There's 2 commits up on GitHub now. And if he wants to tell me that he made these changes, he's going to issue what's called a pull request. So he comes to this little interface here, types a message to me. This is directed to me, Mojambo, and sends that off. And what I'm going to be able to do is, on my end, I'm going to see that come in. So here's me coming back saying, hey, someone sent me some work that I might be interested in. He sent me a pull request. So let's look at that. Now it's back to Mojambo. That's me on my account. I come into my little inbox here and I see a message that says, someone sent you a pull request. There's a couple of different ways that I can look at that content and review it and see if I want to pull it back in. So here's the message. I can click on the commit itself and see the code in reality. I can go back to my fork of it and then look at the network graph. The network graph is a nice, easy way to see what all content is available and who did it. So right here you can see there's 2 forks. Each horizontal line here is a different repository. And because of how Git works, we can map how they connect. Because each commit points to its parent, we can map connections across even different repositories. So these are 2 different repositories, but because of how Git works, I can show you exactly where someone branched off and started doing extra work. So I like to think of this view as a bit of a to-do list, where I can go down each repository, and see what's new, what I need to address in each repository, in each forked repository. So this is one of the views that I use the most on GitHub to see what other people are doing to contribute to my software. If you click on one of those little dots there, then you can see the diff of the commit that was made. You can review it that way. And if you go to what we call the fork queue, you can see an alternative view that shows you in a more list mode what people have done. You can go in here, you can select commits individually, and you can actually cherry pick those, which is to say choose a specific commit or a number of commits and apply each of them to a branch of your choice on your repository. You can do that all through the interface. You don't even have to go to the command line. You don't have to pull those commits down locally or anything if you want to use that interface. It's a way, a lot of people use it to pull in things like documentation, little fixes, things that you don't have to pull down and test locally. If you just want to pull them in real quick, then you can do it through the interface. And the way that Git is built makes it possible for us to create tools like that. Git's very flexible on the back end. So now I've reviewed this content. and I want to pull those changes back in. I'm not actually going to use the fork queue in this instance. I need to test some stuff maybe. I want to pull it down locally and do the merge with git locally. So I come back to the command line here. We have a tool called, it's called the GitHub gem. It's a little Ruby gem that we created that makes it easy to script sort of more complex commands, and it scripts some interactivity with GitHub to make things a bit easier for you as a user. So in this case, it's installed, and it's called just GH, short for GitHub. That's what we call it, the command to call it. So this command, GH network fetch, is going to go to GitHub and pull down every commit from every repository that is in that network of the project. So whatever is on GitHub, I'm going to pull it down locally so I can work with it without typing a zillion commands. Just one command, and I get everything. And then I can deal with it and merge it locally. So here it says it fetched everything from Mojambo and everything from TPW, everything in the network. This command here, GH network commits, shows you basically the same view as the fork queue. It just says, here's the commits that are available, and a little display of their message and whatnot. In this case, I see this commit, and I say, hey, that README is pretty cool. I want to merge that in. So all I have to do is copy the SHA. With Git, every commit is addressed by a 40-character SHA, SHA-1. And this is just 7 of those letters, but generally there's not any conflicts. And so you can use just 7 letters of it as a shortcut. So here I copy those 7 letters, and I run a command called git merge. And I paste in that SHA. And what it did locally here is apply that merge, so pull in that commit, merge it into my branch, because I'm on master branch, and I pulled in some commits from a remote branch. So those exist in the repository, but not in my working directory or my working place. And when I do a merge, that's going to pull them into my master branch. So I've just added another commit to my master branch, which this other guy contributed. If I run git log, then you can see visually that there's now 2 commits, my first one, and then the better README, which has been applied right on top. Now, all I have to do again is git push origin master to take that new content that I have, that new commit I have, and push it up to GitHub. If I go back to GitHub and I hit refresh, then you'll see right here that in my repository, in my fork, now that commit also exists there. If I go to the commits tab, I can see, similar to the git log, that that commit is listed there. On the network graph now, because I pulled in his commit into my repository, his isn't going to be shown anymore because I already have that commit. The network graph only shows new commits that do not exist in my repository. So once it's merged in and pushed up on my branch, on my fork, then that's the only place I'm going to see it. He still has it on his. The TPW repo still exists. It's just that he has nothing new that I need to look at. So that's why I think of it as a to-do list. Because you can go down it as you merge things in, they'll disappear from this view. And you can see there that that was the TPW commit. And so that's a short overview of movies that make GitHub very easy, very simple. You can get way more complex than that. We had a question here?
If you were cherry picking commits, would it, and say you only accepted some of them back in, how would that view reflect that? I mean, is there a way to mark the commits that you didn't want to take as being done or something so that you don't continue to see them?
Yes, so the question is, what happens to cherry-picked commits in the network view? Is there a way to hide them? Do they go away automatically? Right now, they don't. Right now, cherry-picked commits, because they have a different timestamp and whatnot, they have a different SHA, right, which is what you're alluding to.
Right.
So they'll still appear. Now, what we would like to do is, in the fork queue, there's a way to ignore commits. We'd like to carry that information over to the network graph so that you can ignore things. So we're working on this. That'll be, the network graph is a complex piece of code, and it takes some time to work in, but it's slated that we're going to do something like that because I want that functionality as well. So yes, in the future, we'll be able to do that. All right, so our goal at GitHub in general is to make version control awesome, and we do this in a few ways. We like the ideas of social networking. We think that developers in general work more effectively when they work together. So if we can get a group of people in the same place and have them collaborate on code and be able to see each other and what everyone is doing, then this makes us all more effective. So let's take the ideas of a social network and add on top of that code hosting for Git, and let's create a site that makes it easy to share and collaborate on code. And that gives us GitHub. So how are we going to do that? These social aspects that we have, this is a few of them, but some of the main ones, is that GitHub is user-centric. In the URL, you notice that it's github.com/mojambo/endo. Note that anyone can create a repository called Endo. It's not like on SourceForge where there can only be one Endo project. On GitHub, there can be as many as there are users. Everyone can have their own project name that if they want. That's how forks work. There's a Mojamba/Endo and a TPW/Endo. They're both the same project, and they both have the same name, but they're scoped by user. So we put users first. We say, you can create a repository named whatever you want. And people can fork that and have their own copy of that repository. So that deciding which is the canonical repository and who's in charge becomes a social issue instead of a technical issue. And that's where we think that belongs. So it's user-centric. We have a way to follow users. And we have a way to watch repositories. So in your dashboard, you can then see lists of all the people that you're watching and the actions that they're doing, if they made commits, if they edited a wiki, whatever they're doing. You can see that. You can get an RSS feed of that. You can see it in a bunch of different ways. Just allows you to keep tabs on what you find important in that ecosystem. We also have the notion of profiles, so you can go to someone's profile page and see a list of their repositories, when they've been working on them. There's little graphs that say when they made commits to them, so you can keep tabs on who's working on what and to what degree, and if they're responsible for a project. It makes it easy to see who's responsible for code in certain places. On the code hosting side, some of the things that we found very important. We wanted to make creation of repositories as simple and easy as possible so that it's a single step with only one required field, just a name. And from there, you can put your code up and start doing what you want. We think the barrier to entry for creating repositories should be basically zero. First-class forking, meaning that forking is something that you do that's normal. It's not frowned upon. Nobody's going to go crazy if you fork their project, because if they do, it probably means they're going to contribute back to it. So forking is all good. Pull requests, which we went over before. We want to make those easy to send so you can inform people when you've changed stuff. And then a whole layer of powerful visualizations like the network graph. And we have all other kinds of graphs available for you to visualize and look at your code from a higher view to see what's going on and who's working on them. A couple of stats to say that we know that this is working and we know that this is something that people like. Right now, there's about 90,000 unique repositories on GitHub. That's not including forks. That's just unique, totally different code repositories representing different projects. 10,000 of those were created in the last 30 days alone. So we're experiencing a tremendous amount of growth right now. 12,000 of those projects have been forked at least once, meaning that someone came in and said, hey, your project is really cool. I want to contribute. So they forked it, and they intend to work on it. In all, there's about 135,000 repositories, some of those being forks and some of those being originals on GitHub. So we've created this huge, broad ecosystem of repositories and coders on GitHub that are creating software in different ways than they used to, in a much more close-knit, free way than before. One last little thing I wanted to go over. This is an example of how GitHub is working. You can see here a project called Click to Flash, which is a Safari plugin that allows you to hide all Flash. It replaces it with a little thing, and then you click on it if you want to see that Flash content. So it speeds up your browser, etc. It's kind of nice if you don't want to see Flash content all over the place. This project was on Google Code before, and they moved over to GitHub. And since then, they've experienced a just ridiculous amount of contributions from people coming in. So on the right here, where the arrow is right now, you can see that there's, and this screenshot is actually from a couple of months ago. So it's even more than this now. But at the time, there was 319 people who were watching this repository, so they get updated when things change. And there's 95, what does that say? 32 forks of it. So 32 people came in, made forks, and now they've started writing their own code on top of this to commit or to contribute stuff back. So if we scroll down, you can see in his README, he says, here's where the Google Code release was. It came over to GitHub. And now you've got this huge list of people that have contributed via GitHub. Because the barrier to entry, forking is so easy, people come on and say, hey, I wish Click to Flash did this feature. They come on, they fork it, and now it's done. You can really see this in evidence on the network graph. The one I showed you before was very simple, but here's one that's a bit more complex because of all of the commits and collaborative code that has come in. So you can see all the people on the left, and you can scroll this guy around, and you can see all these commits from different people on different repositories, on different branches, and you can explore this and see what's going on, and the maintainer can come in here and use this to figure out which of these commits are relevant and should be merged in. This just goes to show you how blossoming this code collaborative stuff can get when people come in and they see that they're allowed to change stuff. They don't have to have permission to start changing stuff. They just get their work done, and tell the guy later on what they did and have him have a really easy way to merge that in. So that is a little phenomenon we call the GitHub effect, which is when you make your stuff easy to work on and you give permission to work on it, then they'll actually help you work on it. That's what we call the GitHub effect. And that's my presentation. Thank you. And next we have Chris.
I am Chris Wanstrath, and that's my URL with a picture of someone on it and a lack of information. So how many people are already using Git? OK, great. I'm going to talk a little bit about Git workflows. This is about Git. I use the word Git a lot, but really this applies to any of the distributed version control systems that are out there right now. A little bit about me. I play guitar. I have one like that. Mine's much prettier. I'm from Cincinnati, but I currently live in San Francisco. So I started out as a lowly paid consultant, and then I got a job at CNET, which is now owned by CBS. And I left there to become a highly paid consultant, and then I founded GitHub with Tom, and that's where I work today. So I'm going to talk about Git, a little presentation called the Lean Mean Distributed Machine, and I'm going to see how slow I can make myself talk, because I talk kind of rapidly, inadvertently. So the first thing that I like to talk about when talking about Git workflows is the history of version control and where Git fits in and where it kind of came from. So for anyone who's never heard of version control, or if my mom's watching this, what version control is it's like Wikipedia, but instead of being for encyclopedia articles and information, it's for code. So you can use it to see what other changes people have made. You can use it to inspect the changes that they've made. You can get alerts on them. And you can contribute your own changes using something with version control. People can be on the same page. They can see what you're doing, and you can see what they're doing. So Git is a version control system. And who uses it? Yahoo. That's it. That's the only one that matters. Now, these are some of the companies that are using it either for open source stuff or internally that we know about. And then there's a couple of big open source projects that are using it. PHP just moved to Subversion from CVS, but they have an official Git mirror on GitHub, which is pretty cool. They have something like 25,000 revisions in their repository. So they discourage people from mirroring it themselves. They just want them to use the official Git repo. So the history of open source version control. I'm not going to talk about BitKeeper or any of the proprietary ones, because who cares about that stuff? So the first version control system that we care about is RCS. It came about in the 80s. And as I understand it, since the 80s, like 100 years ago, this could be totally made up. But a professor had some students. They were collaborating on a C compiler, and they needed a way over the summer to get their changes to each other. So they devised this RCS system that let them version individual files. They could have multiple versions of a single file. They could see who made what change and when. And so what they did is they threw a bunch of these little RCS databases into a directory, and they worked on their compiler that way. And it worked great. 10 years later, this thing called CVS came out, the concurrent version system. And what this let you do is they hacked in public authentication, so anyone could clone a repository. They could pull it down. I could look at your project without you giving me the keys to the kingdom, which is the only way you could work with RCS. It also let multiple people work on the same files at the same time, and the big innovation was it versioned directories. And what CVS really was a way to manage our RCS repositories, RCS databases. I don't know if it still works that way, but originally it was just glue that brought a bunch of RCS files together under one directory, or a bunch of directories. So it's like a cabin. A cabin's kind of like a hut. It's just a little bit better. It's still kind of crappy, though. 10 years after that, we got a new system, which we call Subversion. So Subversion was like a better CVS. It did all the things CVS did, and all the spots that were sort of pain points for CVS, such as deleting directories, adding new ones, anonymous authentication. Subversion did really well. So it cleaned up all the things that CVS did poorly, and it added new stuff that was cool as well. All of these three version control systems, they're all centralized. And that's important because Git and the other ones in its class are not. So what does that mean? In a centralized version control system, you have a server, and then you have committers, us, the code monkeys. What happens is I, code monkey A, I commit to the server, and then code monkeys B and C, which are Tom and Scott, they pull down my changes from the server. And they get them, and this is how we do the collaboration and the Wikipedia model that we're talking about. We've all realized, at least all of us Git and Mercurial and Bazaar users in the past couple years, that this is bad. It's like a spare tire. It works, but you don't want to go too far on it because it'll screw you over. Why? Why is this bad? Well, in this model, the server is your babysitter. You can't do anything without the server's permission. You can't do an SVN log. You can't get a diff of a commit. Everything you do goes over the wire, which is bad if the server goes down or you're not connected or you just want to get some speed out of it. It actually is pretty slow. The other thing that's bad about it is low visibility. And what I'm talking about here is seeing what everyone else is doing, being on the same page. Subversion in those systems, they don't offer a really good mechanism for that. They're just for versioning code. There's no real bigger picture there, which the distributed version control systems, kind of by accident, figured out how to make better. So we used Bugzilla when I worked at CNET. And it was great because I Googled for Bugzilla, and I wanted to find a screenshot of it that was just like a caricature of it. You know, it's so complicated. And this was the advanced search page on the Bugzilla homepage. So I didn't even need to find someone making fun of Bugzilla. I could just find an advertisement, and I think it speaks for itself. So we used this, and we plugged Subversion into this. And it worked really well because we had people dedicated full-time to managing Bugzilla. But that's rare. We were a big company. Yahoo's a big company. For guys like us in a small company, Bugzilla would just be a nightmare. So what would happen is someone would make a commit, and everyone would get emailed a diff of the commit. So we could all be on the same page. Of course, we're in a 25-person development team with 3 different websites, and we're all getting the emails from everyone because that's how you do good visibility. And so what I'd end up doing is just throwing them all in my spam folder and never looking at anyone else's stuff. Because a lot of the emails I was getting, they were Greek. They were just unintelligible to me. And with Subversion and these other systems, you kind of have to set this all up yourself. So there was someone setting up the emails, and once they set it up and they got it working, they didn't want to mess with it. So fine-tuning it and listening to a junior developer was just not part of the question. I spent a lot of time throwing away the junk, and I thought the emails that were for me and the commits that I cared about should have been the only things I was receiving. I shouldn't have to sort through that. If you're lucky, though, you can use Track, which is really cool, and it has RSS and offers a little bit more visibility. But Track is something that you install locally, and you have to set up and manage yourself, and you have to sort of do all this administrative work, which you don't want to be doing. It takes away time from the coding. So the other problem with the centralized model and the Subversion kind of idea is that your workflow, it's single-threaded. You can only do one thing at a time, ever. And if there's a big fire or an emergency when you're in the middle of writing a feature, this can be a problem. I know anyone using Subversion has had the instance where there's files you're working on, they're dirty, you need to make a bug fix, so you commit and make changes around the dirty files, making sure that you don't commit them in, right? Because you just want to focus on these other files. That's crazy. That's work that a programmer shouldn't have to do. You need a smart tool for that to do it for you. You should have a smart tool for that. So this is something that the distributed version control does really well. Another part of the single-threaded workflow is that when you do a branch, when you do an alternate line of development and you work on it, like a big rewrite, at the end of it, you get into this thing you call merge hell, which is where you have a big meeting. You sit there for 3 hours. You figure out what needs to be merged and who's going to do it. You delegate the guy who didn't even work on the project to merge in the changes. And then at the end of the meeting, he's writing code that he doesn't even know about, fixing bugs in systems he's never even seen before or understand, really. And usually that guy quits a couple weeks later. So I was that guy one time, and that slide kind of summarizes my feelings doing the contracting job, being the merge hell guy. So the other thing about this centralized model is all your experiments, all your embarrassing code, all the things you want to play with, they're all public. So if I want to work on this crazy new feature, but I don't want anyone else to see it yet because I'm sort of insecure about it, I'm not sure if it's even going to go anywhere, with Subversion, if I want to commit in, it's going into the repository. Or else I have to set up my own repository, I keep it private somewhere. So what I end up doing is not version controlling my code, which is not cool because I'm experimenting. Maybe I did something by accident earlier on that I want to bring back later. It's just version control is always a good idea. Everything's public. Everyone sees everything you're doing. You don't want to commit, so you don't. And that's just for work stuff. For open source, it's extremely hard for that same reason. You don't want to be committing to a repository on your experimental branch, having people download it and use it, and telling you they have bugs in something you don't even care about. So what is the answer to all this? And I think it's distributed version control and Git. So Git was invented by this guy, Linus Torvalds, who built Linux, which I think you guys might use here. So if RCS is a hut, and CVS is a cabin, and Subversion is a house, I would say Git is a castle, or a ninja, or Shaquille O'Neal. So what's different about Shaquille O'Neal? This is the model we were talking about before that RCS, CVS, and Subversion all had in common. In Git, you don't have a server and committers. You just have servers. It's distributed. This is the crux of it right here. And so you sort of have the same workflow, or you can have the same workflow where I'm working on a code, I make a commit, the other guys pull it down. But because all of us are servers, it means I can commit to CodeMonkey B, and CodeMonkey B can commit to me, and we can share changes at this other level. So instead of checking out code, you make a clone of a repository. You make a clone of a server. That means that if GitHub explodes, which has been happening a little bit lately, Or if your Git server goes down, it doesn't matter. You have a copy of the code with you at all times. So because you have a full copy of your repository with you, like the idea of GitHub going down gets less and less scary, because you can have GitHub internal server and S3-based backup Git server. You can push to all three of them at the same time on every single commit and not worry about it. That's not a special feature or a hack. That's just the way distributed version control works. There's a lot of cool little self-hosted and public-hosted Git sites that you can use. A lot of people push to the different Git hosting sites. And I mean, we encourage that. Yes, put your code on as many sites as possible, including GitHub. So another word for clone or copy in this new language that we're trying to invent is fork. And it does seem like anarchy if everyone's a server and everyone's pushing and pulling to everyone else. This is kind of what you run up against first. It's like, well, how do you know what to Git? It's crazy. But over time, a couple sane workflows have evolved. And the first one is what we call anarchy. So in this workflow, you remove the server, and you make everyone a peer. And then you take away commit access from everyone else. So I can no longer push to other people. I can only pull from them. So what happens is I pull from him, he pulls from me, and they pull from each other. And we all just sort of share commits. And because this is the way Git's designed, where we're all servers, it's not that big of a deal. As long as I know his endpoint, his URL import, or his IP import, and he gives me permission to read from him, I can pull down his code, I can merge it in, I can manage the different servers, and this is all built into Git's interface. It's pretty cool. So when you're working with something like GitHub, like Tom was saying earlier, GitHub is really just one of these servers. It could easily be one of you guys serving a Git repository right now. So on GitHub, if I wanted to add a patch to Scott's project Ticket, the workflow that Tom just showed us, I would fork it. And what that does on the server is it makes a full clone of his repository. The same thing that would happen when I download it. Then I would make my change. He would pull from me, that sort of thing. The second workflow is the one we call blessed. And blessed is a little bit nicer than anarchy, because anarchy doesn't really scale. It's just kind of crazy. Everyone's pushing and pulling from each other. And if you have a real project and you're doing releases, it doesn't work, because you need to care about a central line of development and get everyone on the same page. So with the blessed repository, it's the same idea as anarchy, but you're like, this is the canonical repository. And it's sort of a social thing. Scott started the project. Scott is the one doing all the work on it. His repository is the one that all of us forkers go to see changes. I don't really need to look at the other forks unless I want to. Instead, I just focus on Scott. And I trust him to pull in changes that he thinks are relevant, and I'll get them from him. So it's the same thing as the anarchy workflow, except Scott is sort of the point man. And we can still push and pull changes to each other, but we don't really want to. And one of the things that GitHub does and other Git hosting sites is they open up this sort of pushing and pulling to each other. You know, it's cool to talk about anarchy, and all of us can have Git repositories and be serving them. But it's like, if Tom makes a change to a project of mine, and then he's like, oh, yeah, I'm serving it from my computer. It's like, what? Where? I don't know how to get to that. Like, OK, set up a VPS, set up a Git daemon, open up your router, do port forwarding. It's like, no, just throw it on GitHub, throw it on repo.or.cz, put it up there somewhere. So it's not really as anarchaic as you might imagine, because there's still limitations with firewalls and hassle. And it's much easier just to use a site and click a button. So in the business world, this works really great for dealing with contractors, because you have a blessed repository. You let your contractor fork it, and then he never gets write access to your canonical repository, to the GitHub code or to the Yahoo code. Instead, they say, you know, I've finished my work. I send a pull request or whatever, and you check it over, and you pull it in. If there are a bunch of us working on Ticket, like I said, Scott's would be the blessed, and we would just watch his changes and pull them down. Rails, Ruby on Rails, this is how it works. There's Rails/Rails, whoops. And that's the canonical one. Everyone watches it. Some of the people working on Rails, they have their own forks of it where they do experimental stuff and they share with each other. But at the end of the day, this is the repository you watch. This is where the packages get built from, that sort of thing. Click to Flash works this way too. Tom was talking about it before. Click to Flash, Wrench took over the main repository when he moved it to Google Code. And there's like a bunch of forks. I think there's 78 now. I was just checking while Tom was talking. And his is the one that you follow, Wrench's. He is in charge of pulling in all the forks, managing the patches. You can look at all the other ones if you want, but you're better off just looking at his, because he's pretty proactive in managing it. Blah, blah, blah. The next one's Lieutenant. Does anyone know who this guy is? So the Lieutenant model, it's the one that the kernel uses. And you still have the blessed repository. And you have this other layer of blessed repositories that we call lieutenants, because that's what the people in the kernel call them. And the lieutenants are in charge of subsystems. So for a system like the kernel, you're not going to have a Scott Chacon keeping the whole thing in his head, managing it, because it's a really big, really old project. And there's very specific things like drivers and networking that you might not even know about, even though you're the person that started it. So instead, you just delegate it to the experts. And the experts are in charge of dealing with all the little forks and patches, reviewing them. Like, and pulling in their changes. And then, so this guy wants to work on the networking stack. He's going to go to this lieutenant because he's the networking guy, go off of his fork, and then ask the lieutenant to pull his changes in. Once the lieutenant has signed off on them, the blessed person can just say, OK, I trust you. You know more about networking than me. I might look them over, but I'll pull in your changes. And then it gets into the sort of, I went a little nuts there with the arrows. Like I said, this is the kernel's model. And the final one, and one of my favorite things about distributed version control system, is centralized. Git can still do the subversion workflow. I mean, that's how we use it as GitHub. There is one central repository. We all have write access to it. We all push to it. So there's nothing subversion can do that Git can't do. But there's stuff Git can do, a few things that subversion can't do. So this is the traditional babysitter model. There's a server. All of us push and pull to the server. We never know about each other. The deploys come from the server. We might even have a staging server. And it's cool because with Git, when you're talking about branches, you can actually pull from the staging server. So instead of having a staging branch and a production branch, what you can do is you can push up your branch working on bug fix 38, and you can deploy that to staging, which is really neat and pretty easy to do. And that's how we do it. So like I said, with the branching, it's cool because it's multi-threaded. You can be working on a bug, and then you made a new branch, and or a feature request comes in, a really important one, a P1. You can just switch back to the main line. You can make a new branch. You can work on the feature, go back to the main line again, merge in the changes, push it up, and then go back to your bug, pulling in the feature you just made, and continue development. And it's really easy. That's just one of the things you do very often in Git. So like I said, it changes the idea of staging servers. Now you can kind of embrace this sort of cloud thing that's going on and have staging servers that are all tied to specific branches and put them out in the cloud, that sort of thing. Small teams. Some of these charts I don't even know what I was thinking. I even have notes, and that's insane. So with GitHub, Tom sort of talked about all this, but one of the things we try to do is make all this visible in a way that other things like Track have done in the past. We want to up the ante and sort of tie all these distributed servers and forks and chaos into a nice interface, make it simple, and kind of make it fun. This is why we have service hooks and that sort of thing where you can integrate with existing services. So instead of us trying to be the best bug tracker, the best everything, we just let you write your own service hooks, contribute them, and integrate with other sites. And we're all about the visibility. Like I said, I hated getting diff emails. I hated Bugzilla. We want you to use what you're comfortable with, what you like, and make it simple and make it work. Yada, yada. So I'm going to talk very quickly about some of the Git support, because it always comes up, I would love to use Git, but Subversion just works so well with Eclipse and that sort of thing. And Git is still young, so it's still growing, and there's not as much support and not as developed and mature an ecosystem as something like Subversion. But there's still some cool stuff to look for. If you use TextMate, there's a Project Plus extension that gives you this sort of, stuff is going to be deleted, stuff is dirty, stuff is being added view into Git that you're used to with something like, I don't know, Tortoise SVN. There's the Git TextMate bundle is available on GitHub, and that lets you do showing logs, committing, creating branches just from TextMate. There's eGit, which is a plugin for Eclipse, which is cool because it includes a reimplementation of Git in Java called JGit. So it lets you do some crazy stuff. There's DVC, which is a sort of interface to all the version control systems that's available for Emacs. So you can use Git, if you're familiar with DVC, the same way you use CVS or Subversion. But why would you want to do that when there's Magit, which is the greatest of all the Git IDEs and the one I use, and it lets you do crazy stuff in Emacs with Git. If you use OS X, there's an open source program called GitX, and it does all the things you would expect. It also lets you do staged commits, which are a great Git feature that I don't think it's talked about a lot. And what that does is it lets you look at a diff, changes you made to a file, and you can commit just parts of those changes. So a lot of times what happens is I'll be working on an open source project, I'll make my change, and I'll realize that my editor stripped out all the extra white space. So there'll be all these changes I made that I don't want to contribute. I'll go into the staging mode, I'll pick just the code I want, I'll say this is in my commit, I'll submit that commit up, and I'll just say forget about it. They can deal with the white space on their own. It's really cool for doing that, or if you're managing a bunch of things in one file and you have some sort of debug statements that you don't want to commit, you can sort of tiptoe around those and just commit the meat. There's Git GUI, which is GitX aims to be a cross-platform version of. This comes with Git, I think, if you install it on OS X or Linux. You can just run git-GUI and fire it up. And then there's GitNub, which is pretty simple. I don't think it's under active development anymore, but it's an interesting Git interface that's pretty pretty. It's simple, though. I don't know. I just like looking at it. A search on Git when I wrote the slides returns 3,000 Git-related projects. I think the only other term that probably has more results is Twitter with all the APIs and sort of thing. So very quickly, the other things you can do with Git, it's a content addressable file system. And the kernel guys, all they know how to write is kernels. So when they wrote a version control system, they basically wrote like another kernel, or a file system. And so it means you can do really cool stuff with it. We have a paste bin where if you're talking to someone on IM and you want to show them a little snippet of JavaScript, you can go in here, paste in the JavaScript, get some colors, and just send them the URL instead of sending over the code. And the way that this works is instead of keeping the code in the database, we keep all the code in Git. So each paste that you make is a full Git repository that we just make it on the fly. And you can fork it, you can clone it down. I do this a lot for simple bash scripts. I have a bunch of stuff that I keep in gist, and I'll version it. I'll work on the bash script. I don't want to have it as a project in GitHub. I just want to keep it somewhere simple and push to it. I'll also do this with private gists. You can do a .markdown or .text style, and I'll work on little documents with people, like a to-do list or ideas, and we'll iterate on the same project really quickly with gist because it's just a Git repository. Blah, blah, blah. These are the arrows. So I think this is my side. This is the future. I like it because this looks like it's not really the future. I think that's a real one. But this kind of stuff is really exciting to me because now that the tools are getting easier with our site and other sites, Git's interface, the other DVCSs, we're starting to see some really creative uses like gist of this sort of really, really intense and well-designed tool. One of which that's going on right now are books. Lots of people are writing books on GitHub using Git collaboratively. So they'll put up the code of the book. Anyone will be able to fork the book, add whatever chapters they want, and then they'll publish the book from the mainline one. So this is the MERB internals handbook, and then there's a Grails internals handbook. Scott Chacon today published his pro-Git APRESS book, Creative Commons on the Internet. People have already forked it and started working on Ukrainian and Portuguese translations. So Scott did another website, or a couple websites actually, that he put on GitHub. People have forked them and translated them too. One of them is in like 14 languages. It's, yeah, 14 languages. I didn't even know there were that many. But yeah, with stuff like writing, we're just talking about versioning plain text. So you can take a lot crazier. I mean, people have talked about iPhone apps that are just note-taking apps that actually back up to gist. Cool stuff like that. This is another future thing. So this is want more information on Git, you can go to git-scm.com. And that is it. Does anyone have any questions? Amazing. Thank you very much.
I work at GitHub. I have a bunch of Git-related projects. My thing is schacon, github.com/schacon, so a lot of Git-related stuff. I run gitscm.com, so I'm actually the maintainer for this site. So if you do go here as like a resource, there's some really good resources on here, and you can go to here to download tarballs and stuff. And you see something particularly wrong with the site, you can email me directly because I'm responsible for it. I wrote the Git peep code PDF, Git internals, if you want to learn more about some of the backend stuff. And like Chris mentioned, I wrote an APRESS book that's going to print right now called ProGit. And you can get its Creative Commons license, so you can read the whole thing online at progit.org if you guys want to learn more about Git or reference like certain chapters for tips and tricks and stuff like that. Most of the stuff I'm going over today is referenced in detail in the book. So if it's interesting to you, you want to share it with somebody, it's a good place to look it up. So my email address is schacon@gmail.com. If you have any problems with any of this stuff, I am to blame for all of it. OK, so really quickly, what Git is in 60 seconds. So Git is an open source distributed version control system that is implemented as a directed acyclic graph made up of commit objects that point to snapshots, that is implemented as a content addressable file system where every object in it is implemented as a namespace by SHA-1. You could do branches very easily, and they are implemented as pointers into this directed graph. You know what? I'm just going to go through this. I had notes where this actually made sense, and they're missing other things. So I was just going to go over what it is really fast. You guys can follow it if you can. All right. All right, so it's OK, because I'm running out of time anyway. So, all right, so Git tips and tricks, some stuff that you can do. I'm going to go over a couple things. One is data munging, so some data manipulation stuff that you can do, some debugging tools that you have in Git, and some ways that you can customize Git to be hopefully more useful to you. So, data munging. One thing is rewriting history. So, one way that you can rewrite history is to modify the last commit. So if you committed and you forgot a file or something, you forgot to add it, to start tracking it, and you want to go back and just replace your last commit, you can add it and then run git commit -- amend, and that will just replace the last commit you did on the branch that you're on with whatever your staging area looks like right now. So if you wanted to undo a commit and just like rewrite it or rewrite the commit message or something, you can use git commit -- amend, so that's very helpful. How many of you guys rebase? Use rebasing? OK, so some. All right, so this is just a description of what rebasing is, since it's somewhat unique to Git. If you have this is sort of what the Git history looks like, what the object history looks like. It's a directed graph of commits, so each commit points to the commit that came immediately before it. So if you fork, if you create a branch and do some work on that, and then go to like your master branch and do some work on that, then you have this sort of forked history, right, where you have two different heads. So there's a couple different ways that you can put these together. You can merge them together. So if you're on the topic branch and you say git merge master, creates a new merge commit, and all that work is sort of incorporated. But the other way that you can do it is you can create a linear history, right? So if you are on the topic branch and you say git rebase master, what it'll do instead is it will look at what you gave it on the command line, whatever branch you gave it on the command line, which is master, which points to C5. It'll find the first common ancestor, which in this case is going to be C1, so wherever you branched from. It'll take all of the patches that were introduced, all of the commits that introduced work on the side of the branch that you're on, whatever branch you're on when you run this command, and it will extract each one into a patch and stick it on a stack, right? So it'll basically run something like this. It'll get the patch that was created between C2 and C3, and it'll create a diff file, and it'll stick it on a stack that you have. And it'll do the same thing for each one all the way down the line. So in this case, we have two, right? So it'll take this one, and it'll put this on the stack as well. And then it'll go to whatever branch that you put on the rebase line there, and it will start applying these off of the stack on top of that. So you'll get the same work that was introduced in C2, but it'll reintroduce it on top of whatever commit that is, right? So that's basically what rebase does. So now, instead of having a merge commit, you end up having what is closer to a linear history, because it takes all the work that was done in one line of work and then just replays all of that work on top of anywhere else that you want to do it. So that's what rebase does. There's a couple really useful things you can do for this. One is if you're working on a branch and then the head moves, right? So somebody else is committed in the meantime, and you want to supply a patch series to them over email. You probably wouldn't do this internally, but you might if it was an open source project. You can rebase on top of the new head so that you make sure that all of your commits, all the patches that you're going to send in, apply cleanly to where they are right now, right? So you can work on some topic branch and then rebase them on top of wherever the current project is. The other thing is if you're using Git SVN, I don't know if you guys are using Subversion, and some of you might be using Git SVN, you have to keep a linear history because Subversion only has a linear history, and so you have to rebase in order to decommit. So some fun things that you can do that you may not know about if you don't use rebase, or even if you do, is you can rebase onto somewhere else, right? So if you want to transplant a topic branch, you can have a couple commits. Let's say you create a branch called server, you do a commit. You create a branch off of that called client, you do some more commits. You go back to server, do some more commits. You go back to master, do some more commits. So now you have sort of all of these branches, right? And you want to move the client work onto your master branch, but just the client work, not any of the server-related changes, right? So the problem is you created the client branch off of the server branch rather than off of the master branch. And so the idea is, how do I just take these and move them up to master? So you could try git rebase master, but what that's going to do is find the first common ancestor, which is C2, and then identify all the patches down one stream. And so that includes C3, and you don't want that. So you can't do that. You could try git rebase server, which will work properly. It'll find the right commits, but it'll put them onto the wrong place. It'll put them on top of the server branch instead. So what you can do is you can say git rebase server -- onto master, and that will figure out the patch series based on that one, and then move them to the one that you do after -- onto. So this way you can just transplant a topic branch. So any branches that you have in your history, you can just take them and move them with rebase, which is kind of cool. You can rejigger your history pretty easily this way. And then you can check out server and then just do a normal git rebase master to move just the server stuff on top of where the client stuff was. Right? So now you have a nice linear history, and you can just transplant topic branches that way. It's kind of cool. You can also transplant some of a topic branch by just dropping a pointer. So if you only wanted C4 and C5 to move on in master and not whatever was in C3, say it was like a white space change or it was something you're not ready for, but C4 and C5 you do want to push out. If you do a merge, it's going to take everything downstream, right? If you merge in the branch, it takes all of the changes. But if you just want 4 and 5, then you can move them independently. So what you want to do is create a new branch at C3 to just put a pointer there so that the rebase logic will work properly. And you can say rebase new topic because the first common ancestor will be itself. And and dash dash onto master, and that'll just move those two up. So if you want to take parts of a topic branch and move them independently, you can do this. And now new topic only points to this one, so you can merge that in later, or you can rebase that later, and it'll just take C3. So rebase actually gives you a really cool way of using your topic branches as sort of like patch queues, right? You can think of each commit as sort of a patch on a patch queue, and you can move them around your history independently. It's kind of cool. That's really difficult to do with a lot of other version control systems. So the other thing you can do is fix a commit several back. So if you did some work and you want to change some commit that's in your history, you can use get rebase -I, and that's an interactive mode of rebase. So it gives you sort of a script of what it's going to do, and then allows you to change that script somehow. So if you have a history with a bunch of commits, and you actually wanted to modify this somehow, you wanted to add a file to it, or you wanted to change a commit message, or you wanted to do something like that, you can do that. I don't know if you guys are familiar with this syntax, but that points to, you can just use the SHA instead of that for that particular commit if you want to. What it's going to do is it's going to modify everything upstream. Since all of the commits point to their immediate ancestors and checksum, anything you change, like if I try and go back and change this one, it'll change everything that's upstream from it, everything that came after it, because they all reference it. Git is cryptographically strong that way, so it's hard to modify stuff without modifying everything upstream. But if I run this, which is the parent of that commit, then it'll give me a nice little script, right? It'll put me into an editor and give me all the commits that I have in reverse order, because that's the script. That's the order it's going to try and apply them as. And right now it's all pick, so if I just exit out of this, it'd be the same as just running git rebase. It'll just do 1, 2, 3, and it'll be over. If I modify stuff, so I can edit ones, I can make it stop in the middle, and then I can edit something, or I can squash ones together if I actually want to take 2 or 3 commits and squash them down into one. I can do that. So if I wanted to edit that one, I can say edit, and it'll apply it and stop and allow me to commit amend, so change the last one that was applied. And so I'll edit the files. I can run git add to stage stuff. I can run commit amend to modify wherever it was that I stopped, and then continue, and that'll do 2 and 3. So it'll just apply the next one and the next one. So if you wanted to do a rebase, but you wanted to stop and change something in the middle, rebase -I will allow you to do that. So it's kind of cool. And it'll allow you to squash commits together as well. So if I actually wanted all 3 of these to be one commit, I can do rebase -I, and then just do the first one as pick and the next 2 as squash, and it'll squash them all down into one commit. So it's kind of cool. If you guys have like a code review thing that takes each patch and people have to code review it, and you said, oops, I forgot to do this or something, and commit like an oops, I forgot to do this commit, and you want to squash that down, then this is a good way of doing that. You can use rebase -I. And it'll put you in an editor with the 3 commit messages. Of those 3 commits, you can make one unified commit message, which is kind of cool. And then you end up with something like this, and you can push that off. OK, so there's some problems with this, with the rebasing stuff. Basically, I'm not going to go through this because I'm running out of time. But basically, what you don't want to do, what you don't want to do is you don't want to rebase something that you've already pushed out and somebody has based work on. So if you've already pushed some work out and somebody's actually done a merge with it, you don't want to rebase that work and then push it out again, because what you're going to do is when they push out, you're going to get your original line and then your rebase line in your history as well, and you'll see commits twice. It'll be really weird because you're just cherry picking them onto another thing, basically. Another interesting tool is filter branch. So this filter branch will modify history in mass. So you can modify everything. If you actually accidentally had like password.txt something, or in your history, and it was in like 18 commits, or you put the wrong email address in when you did the import or something, and you want to go through and change your email everywhere, you can use filter branch to do that. So it has a bunch of different options. One is tree filter, which will check out each version of like the whole project or whatever you give it. So this is from head down, so from the last commit all the way down, and remove file name from every single one. So you can do remove -f password.txt. It'll go through and rewrite every commit. This is like a massive rebase. And every SHA changes, the whole history changes. But if you're doing an import or something and you forgot to take out some big file, or you had an installer or jar files or something, you can use this to clean your whole history, which is kind of cool. Or you can change your email if you want to do. This will change the email of every single commit, not just yours. But this is sort of a simple example of doing that sort of thing. It'll go through and change every email of every commit to that email address instead. So if you're doing an import, you need to clean it up. Filter branch is a good way of just doing sort of mass changes of all your commit data. All right, so how many of you use submodules? OK, so I don't know how good this thing will be. So there's a bunch of problems with submodules, and this is another way of doing it. You know what? I'm not going to do this either. Sorry. Everybody get that? All right. I'm not done yet. It still goes. No, I'm still going. Sorry. Oh, so if you're interested, that's the URL. If you go to tinyurl.com/git, if you hate submodules and you want a different way of doing it, this guy wrote a really cool way of doing subtree merging instead of submodules, which is really nice. So I'm going to do patch staging because this is helpful to lots of people, and Chris mentioned this earlier. If you say git add-p, it'll allow you to stage hunks of files. So if you edited a file, for those of you who use Git, you might know that there's a staging area, so you can stage files that you want to include in your next commit. You can also stage parts of files that you want to include in your next commit. So if you did a bunch of like documentation changes at the top half of a file and change some methods in the bottom half of a file, and you only want to commit the documentation changes and not the method changes yet, you can actually stage parts of a file. So if you say git status and you see that I changed, say, this gemspec file, and I say git add-p, what it's going to do is go into this interactive mode where it shows you each hunk of the file diff and says, do you want to stage this particular hunk? And so I can say, yes, I want to stage this version change, but no, I don't want to change. I don't want to stage this stuff that I've done because it's not quite ready yet. And so I can, put no there. And then if I run git status again, it'll show me that I have both a staged and unstaged modifications to the file. So it's like I made the first change and staged it, and then made the second change. And then if I commit, only the first half of the file that I had done actually goes into that commit and gets shared with people. So you can like cherry pick changes out of a file to include it in a commit to craft commits, which is a pretty cool way of doing it. So if you've been coding all weekend or something, and you just have like a whole bunch of files changed, and they're changed all over the place, and you want to make 3 really nice, easily code reviewable commits out of them, git add-p is a really nice way of saying I want these parts of these files to go into the first commit, and then these parts to go into the second commit, and so on, so that it makes sense when people are looking at the commits as individual units. All right, so now some debugging tools really fast, and some of these are really cool. So if you've ever used svn annotate, you know what that does. It goes through and it shows you who edited who edited each line of a file last, right? Which commit was responsible for changing each part of each line of a file. So basically what question you ask is, who did this? And then you say, oh crap, it was me. And then you don't send a flame out to the email address saying, or to the mailing list saying, why did somebody make this change? Because it was me. So if you say git blame some file, it'll show you the last commit to touch each line, and who that person was that committed it and when they did it. So you can go through and say, oh, okay, this is, if you've figured out where a bug was introduced, you can see who introduced it and when it was introduced. So that's pretty cool. But one of the things that Git does that Subversion does not is you can put this -C in. And what the -C will do is it will not only tell you who changed each line, but if a code fragment was copied from another file at some point, it won't tell you the person who committed who did the refactoring. It'll tell you the person who originally wrote it in the original file, right? So in this case, I had a file called git server handler, and I split it into multiple files, one of which was git pack upload. And I took all of this code right here was from the original file. So I had refactored that from git server handler into git pack upload. And I can see that I haven't changed it since I copied it. But it doesn't show me, normally it would show these lines as when I did the copy, because that's when it was introduced into the file, right? But I can see that this actually came from another file originally, and that this is when I had actually originally written those lines, which is really cool. I don't know of any other tool that'll do that for you. Another nice thing is bisecting. So you can do a binary search for where a bug was introduced. So if you have a commit that's broken, has broken unit tests, or is broken on the website, and you know that it wasn't broken, that particular feature wasn't broken as of version 1.0 release or something, you can have Git help you figure out where that was introduced, right? If you don't actually want to go through the code and try and figure out where that was. So if you say git bisect start, it'll start the engine. If you say git bisect bad, it'll assume where you are right now is a bad commit. And then git bisect good, and you can do like v1.0, or if you have a specific commit that you know it worked at, you can put in the SHA of that commit. And that tells it to start the range, right? I know it was good here. I know it's bad right here. And you can give it a v2.0 for bad or whatever, right? If you leave it off, it'll just assume whatever commit you're currently on. And it'll say, OK, there's 12 commits in between where it's bad and where it's known to be good. So I'm going to check out the middle one. And it just checks out the middle one into your working directory. And you can test it, right? And you can say, OK, this one is good. This one doesn't have the bug yet. And so it goes, all right, and takes the difference and checks out the middle one again and checks that out. And you can run your unit test or whatever and say that one's bad. And it'll say, all right, checks out the middle one. And it just keeps doing that until you just say bad, good, until it says, all right, here's the commit that broke it, that introduced whatever change you're looking for. And it's almost always PJ Hyatt, so if you're not working with him, then don't worry about that. But it does give you the thing, and then you just say git bisect reset, and it resets you back to where you'd begun. But at least now you have the commit. You know where it was introduced. You can say git revert, and it'll git revert will apply the reverse diff. It's like a reverse cherry pick. It applies the opposite of whatever is introduced in this change. So you could say, if you had this SHA, you can say git revert that SHA. It'll just undo everything that commit did, right? That might fix it. All right, so some other things you can do to customize it. So for those of you using it on the command line, which I assume is most of you, you can turn on the colors if you haven't already. The colors, the terminal coloring is really nice. You can say git config -- global. The configuration option is color.ui. There's a couple different things you can do for it. There's true and there's always. Always will always do the colors. True will do the colors if the output is to a terminal. So if you're redirecting it into another file, it won't put the terminal color stuff. So I would recommend doing true. But it's nice. It gives you some nice coloring for the logs and the diffs and stuff. Custom merge tools. So if you guys have a merge tool that you're used to and you like, so I'll give an example of Perforce. So if you use Perforce Visual Merge Tool, it's a fairly nice visual merging tool. By default, when you have a merge conflict in Git, it'll put in subversion style merge conflict markers. But you can fire up another program to do the merge conflicts for you or to help you out, right? So if you download the Perforce stuff, this is a free program. You can have something that looks like this instead of having the conflict markers and having to do it manually. And the way that you set that up is you set up a program that'll launch it like that. There's an example of this in the progit.org book as well if you want these code samples. And then tell it, I want to use my merge tool as extmerge, which is this new script I set up. And this is the command to send extmerge for it to work properly. And don't trust the exit code because the exit code of the Perforce thing is crap. So it just asks you instead when it's done. And that's it. It ends up, if you run those 3 commands, you end up having these sections in your git config. And then if you do a merge and it says there's been issues with your merge, all you have to do is type git merge tool, and it'll fire it up, and it'll have everything already set up for you. So you can just use the Perforce thing to solve the merge. So if you like that, you can do that. You can also use kdiff3 or opendiff or Emacs diff or whatever you like to use as a merge tool if you have a merge tool that you like. Some other interesting things you can do with Git. Have any of you used Git attributes or know about it? Okay, so there's some cool things you can do with Git attributes. Git attributes allows you to diff binary files, for one. So if you want to diff an image, normally if you have an image that was changed in a commit and you run git show on the commit or something, or git diff, it'll show you something like this, right? It can't diff the image for you. And so it just says that it's a binary file and I can't do it, but they differ. They're different somehow. But you can tell it how, right? If you can make that file type into something that is diffable, you can tell Git how to do that. So for example, if you run all your PNG files or all your image files through exif tool, you can diff at least the exif information, right? So if you say, all my PNG files, I want the diff to use exif first, so it's like a filter before you run the diff on it, to turn a binary file into a text file you can diff, and you just put that in a file called git attributes and put that in your project, then you can say, and then you have to set it up, right? Diff, exif, that actually, so this is the strategy, and this actually tells it the command to run. Then this is what exif tool normally outputs. So if you actually run git diff and a file is changed, you can get an output that's more like this. So you can see, all right, the file size got bigger and the image dimensions changed, right? So you don't actually see like the diff, but you see something, right? This is better than A and B differ. It's kind of cool. You can also do like Word documents. So if you put in this and just tell it to pipe Word docs through strings, that'll at least give you something, right? So you can get Word documents like at least some sort of diff on them by piping them through strings first, which is kind of cool. But I mean, anything you can think of that would turn a binary file into something that's diffable, you can set up through the git attribute stuff. So some other things you can do is filtering stuff. So if you want to pipe all your .c files through, if you want to pipe all your .c files through indent first or something, you can set that up so that when you're checking them in, it actually runs like all your .c files through indent, and then when you check them out, you can run it through cat or something, right? So that'll sort of automatically run your certain types of files through a program. Some other things you can do is date expansion, so like RCS type style date expansion. If you set up an expand date program, that'll actually take, so in this case it takes the last commit and puts the date into, just replaces this string with this string. You can make git automatically run that. So what you do is you set up a smudge filter and a clean filter, which does the opposite. It just strips that out, right? And so if you put that into a file, and then again, you have to set up this git attributes. You say, run the dater filter on everything, and that's the file that I just set up. And then add it and commit it, and then just remove the file and check it back out again. Then you get this nice sort of string that goes in there. So you can do any type of like keyword expansion that way if you can come up with some way of doing it. So this is kind of cool. There's filters, check in and check out filters that you can set up on your files. I did one thing, I think Chacon/git media, if you're interested, for it'll look for files that are really large, and you can set up like .movie files or something, that if git sees .movie files and they're too big, it will instead SCP them to a server and then put in like a bookmark. And then when you check it back out, if it sees the bookmark, it'll look on the server for something and SCP it down. So you don't actually check in like movie files. You can offload them to like an FTP server or something, which is kind of cool. So that's it. Just some interesting things that you can do with Git that are kind of difficult to learn about. But you can read about all that stuff on progit.org. Has the full version of my book. And it's all Creative Commons licensed, so if you find anything wrong with it, go ahead and email me. But it has examples of all that type of stuff. And there's some really cool things that you can do with Git that are a little bit more difficult to learn. So that's it. Thank you.